Okay, this is lesson 2.4, equation of a circle. This is the last lesson in Unit 2, Analytic Geometry. And we're going to start with, I'm going to show you where the equation of a circle comes from. And it just comes from the distance formula. If we look at a circle, centered at 0, 0 on the Cartesian plane, which means the center's here, if this is our circle, the only thing we really know about that circle as we can calculate on here would be a radius. We can come up with the equation of this circle, and we're going to do that in a second. Here's where it comes from. All we know about the distance formula is the distance from here to any point outside the circle would be the same. That's the point of the circle, because the distance from the center to the outside is called the radius. And the radius is just half of the diameter, but no matter where we're going from the center to the outside, it should be the same. So, if I write an equation for the distance between this point and this point, let's call this point O for origin and P for point, the distance from O to P would be, using the distance formula, x2 minus x1 squared plus y2 minus y1 squared. 0 to P, or O to P. Well, the distance from here to here is also called radius. So we can replace the distance from O to P with just R for radius. Our first point is the origin, and it has the coordinates 0, 0. So if we're filling in our equation, our first point is 0, 0. Our second point is just x and y. So we've got x and y, because it can be any point outside. Let's do a little bit of simplifying. X minus 0 is just x. And if you square x, you get x squared. Y minus 0 is y. And when you square y, you get y squared. So we end up with this equation. R is equal to the square root of x squared plus y squared. And if I square both sides, I end up with this. R squared is equal to x squared plus y squared, which looks a lot like the Pythagorean theorem. And actually this is the definition for the equation of a circle centered at the origin. So all the circles we're going to deal with in this unit are centered at the origin 0, 0, and they'll always follow this equation. The nice thing about this equation is the only thing you ever have to be able to fill in is R for radius to write the equation. So if I look at the circle we have here, the equation will be x squared plus y squared equals r squared. Just like the equation of a line's y equals mx plus b, a circle also has an equation. When we write the equation of a line, we fill in slope and y-intercept, the m and b, and we have x and y as our variables. Well, we're going to keep x and y as our variables. We're just going to fill in r. On this circle, r is 4. So we fill in 4. And we end up with this. What's 4 squared? 16. X squared plus y squared equals 16. This is the equation of this circle. Let's try one more. Determine the equation and the radius for the circle that has its center at the origin and one of the points is 6, negative 8. So this time, I didn't give you any information about the radius, I just gave you an x and a y. Just like when we write equations of lines, we can use points to help us find the parts we don't know in the equation. Well, the equation of the circle is x squared plus y squared equals r squared. If I give you an x and a y, we can plug those in. Oops. 6 is x, 8's y, and r is what we don't know. Well, we can do math to solve for r now. 6 squared is 36. 8 squared is 64. 36 plus 64 is 100. And if we want r, to get rid of the square, we just square root. That means the radius is 10. Once you know the radius, you can write the equation of a circle. X squared plus y squared equals r squared. We know r is 10. X squared plus y squared equals 10 squared, and 10 squared is 100. And there's the equation of our circle. Notice the only thing we fill in the equation of a circle is r. If I don't give you r, you have to take a point, fill in x and y, solve for r, then fill in r. And we end up with our equation. Now the next question says, is point B, negative 5, 9, inside this circle? Well, what's that mean? Well, it means that our circle looks something like this. This is our circle, and the radius is 10, which means 10, 10, that's 0. It'll be negative 10, negative 10. This circle has a radius of 10. And we know 6, negative 8 is on the circle. So 6, that's 5, we'll call that 6, negative 8, right here, that's point A, 6, negative 8. That point's on the circle. The question is, what about negative 5, 9? Well, negative 5 would be like here, and 9 would be like, oh sorry, negative 5, 9. 9 would be up here. So it's asking, like, is the point in this area inside the circle, outside the circle, or on the circle? It actually just asks if it's inside the circle, but we'll be able to tell where it is. And the way you can tell is you can test it. You can do a check. And the way you check is, well, we have an equation that says x squared plus y squared should be equal to 100. So if you take an x and a y and you square them and add them, it should equal 100. And if it doesn't equal 100, it's not on the circle. So let's find out. Negative 5 for x and 9 for y. Negative 5 squared is 25. 9 squared is 81. And 25 plus 81 is 106. 106, and this side is 100 the whole way, those are not the same. In fact, this is bigger, which means instead of being on the circle at 100, it's actually outside the circle at 106. Anything less would be smaller, like 95. It's just showing you how far away it is from the center. Since they're not equal, it means it's not on the circle, it's actually outside. So to check, you just plug in the point and see if it equals 100. If it's less, it's inside the circle. If it's more, it's outside the circle. So this point is actually outside. Negative 5, 9 is outside the circle. And here's your check. If x squared plus y squared is greater than r squared, the point is outside the circle, which is what we have. We have a point outside the circle. If x squared plus y squared is equal to r squared, the point is on the circle. And the last one, if x squared plus y squared is less than r squared, the point is inside the circle. So one check to see whether it's inside, outside, or on. And that's it for lesson 2.4, equations of a circle. What you need to be able to do is find the equation of a circle by plugging in the radius, If you're given a point, you need to be able to find the radius and plug it in to write the equation. And you need to be able to check to see if a point is inside, outside, or on the circle by doing a check. And that's it for Unit 2, Analytic Geometry. Thanks for watching, and I'll see you in Unit 3.